Security has to be our number one concern these days. Every day I turn on the news and I see a news story about some company getting their data compromised, being hacked into, or having their server shut down as a result of something like a DDoS attack. Well, AWS takes it very, very seriously, and they provide a lot of different tools to help us take it seriously as well. But the first tool that they provide is called the AWS Shared Responsibility Model. This model is all about what AWS is responsible for securing, as opposed to what you and I, as the users of AWS, are responsible for securing. In this nugget, we're going to talk a little bit about what that model looks like, what it means, and then we'll take a look at the different ways that AWS holds up their end of that bargain with their physical security, the physical access to their data centers themselves, as well as the hardware, software, and network access that they control. AWS is a big evangelist for something they call their shared responsibility model. And I'll be honest, the first time I heard this, I was a little set back, a little put off, because I thought, well, it's your cloud, Amazon. You should be responsible for the security, not me. That's why I'm hiring this out to you. That's why I'm outsourcing everything to you. But it actually makes a fair amount of sense once you get into it a little bit more. The shared responsibility model is really answering the question of who is responsible for what. And in order to understand this a little better, I'm going to talk first through a couple of use cases, and then we'll take a look at what they actually consider their shared responsibility model. So imagine that you're spinning up an EC2 instance inside of Amazon. This is a virtual machine in the cloud. If you're unfamiliar with EC2, go ahead and check out the nuggets we've recorded on that and get yourself up to speed. If you think about what goes on with securing an EC2 instance, well, there's the things that Amazon is absolutely responsible for. We're talking about physical security, which is locks on doors and security guards. They're responsible for all the hardware, making sure that hardware is up to speed, functioning properly, and has proper security. They're even responsible for the hypervisor software that is running those EC2 instances. You and I don't have any access or any visibility to that software. That can't be on our plates. But there are some things that are on our plates. Consider the firewalls, the security groups that are allowing access in and out of our instances, the installation and the updates of the operating systems, even things like applying security patches to those operating systems. That stuff's on our plate. There's a dividing wall there between us and Amazon is responsible for the things on one half, whereas we are responsible for the things on the other half. And this, of course, makes perfect sense, right? You think about setting up a network security group on a EC2 instance. You absolutely could set up a crazy, terrible rule. You could say allow all traffic from all IP addresses inbound to that machine at any point in time. And Amazon has their network security group. It's essentially a firewall that will, in fact, apply that rule to that instance rigorously. But it's a bad rule. You've written a bad rule. You have effectively invalidated an enormous amount of security by configuring that security model wrong. It is our responsibility to configure that tool appropriately. So Amazon has built a tool, and they've built the underlying infrastructure to be secure, but we have to configure that tool. Another important thing to understand with the shared responsibility model is that it's going to change, or it's going to vary from service to service. So this example here is for an EC2 instance. There's quite a bit for us to be involved with. But if you consider something like simple storage service, S3, well, all of this stuff really falls on the side of Amazon.com. It is a platform as a service, and as such, they're handling not just the underlying infrastructure and physical security, but they are also worried about the operating system. They are updating the firewall, configuring the patches, doing all of those things. All we're really worried about is user security, access to the objects inside of S3. We got to set up our IAM rules or set up our access control lists on those S3 objects and buckets. So I think that's two really good ways to think about, or two good use cases for the shared responsibility model, the EC2 and the S3. They're both examples of how, yes, there are responsibilities for Amazon, but there are also responsibilities for us, and that's always going to be the case. There's no point in time when we can solely rely on Amazon to provide perfect security, because they are providing us with a number of tools and a number of devices in ways that if we configure them improperly, we can undermine the security. To put it another way, the way that I like to say it, security is everyone's business. We cannot think that security is someone else's problem or someone else's job. It's everyone's job all the time. And that's doubly true these days, where everyone is trying to protect their systems to the utmost because there are constantly security vulnerabilities being exposed and being exploited by malicious actors. Amazon breaks down the shared security model with this little diagram here. And you can see that they have identified in blue here some things that are responsibility of the customer, while in orange, the things that are the responsibility of AWS. And like you would expect, the AWS things include regions and availability zones, which are basically their data centers, and also their edge locations. When you use the CDN to push data out to the edge locations, hey, it's on Amazon to make sure that stuff is secure and to make sure that those facilities are secure. They also are responsible for the security of the foundation infrastructure, the compute, the storage, database, the networking. The things that are inside their purview, inside their control, Amazon is absolutely responsible for. On our side, things like encryption are our responsibility. We got to ensure that we set up or use encryption when it's appropriate and use it appropriately and secure our encryption keys. We can't encrypt our data and then make our keys public. That doesn't make any sense. Also, operating system and network and firewall configuration, platform and identity access management, and lastly, customer data. We got to make sure that we haven't built a website that just exposes protected information to anyone who browses to that website, right? That's on our shoulders. That's our problem. That's our responsibility. Amazon can't control our application in that way. So it's kind of a double-edged sword here when it comes to developing things on the cloud, because we have to have the ability and we have to have the knowledge to ensure that we properly secure things in the cloud. And this is how Amazon likes to describe it, and I really like this description as well. We have security in the cloud versus security of the cloud. And security of the cloud is Amazon's responsibility. That's what I've represented with this little padlock chain around the outside of the cloud here. Amazon is making sure that the cloud is secure on the outside. But for the things inside the cloud, security in the cloud, that's our responsibility. And we got to make sure with this padlock inside the cloud that we are appropriately securing resources inside of the cloud. Now let's take a few moments to talk about exactly what security of the cloud means and how AWS implements that security. We'll start at the basic level with what I'll call physical security. And this is the very first layer of security that Amazon needs to worry about, and, well, frankly, you and I don't. We just simply need to know that they're doing this. And we're talking about physical access to the AWS data center. How does Amazon retain physical access to these servers? Well, to begin with, the physical data centers are in a nondescript, undisclosed location. You can't really identify AWS data centers from the outside, and you can't go to the phone book and look up AWS data center in your neighborhood and go find out where it is. They keep it private. They keep it locked down. They keep it close to themselves where exactly these things are, so it's not easy to necessarily find one of these data centers. They have security staff, of course, 24/7, highly trained and always available. Anyone who wants access to get entry into one of these data centers actually has two-factor authentication for every individual that's going to get inside of these centers. And then once you're inside the center, there is continual monitoring, logging, and auditing of all activity that everyone does inside of the data center. Even within the data center itself, there are different areas with different tiers of security, so you may be authorized to enter one area and not another, and that ensures that if someone gains access to one area, they don't have access to things that they're not supposed to have access to. So internal firewalls as well as external security ensures that they have high degree of security on their data centers. Of course, that's only the start. Once you are inside the data center, they have to secure the hardware, the software, and the network of this data center. So those data centers are full of all sorts of computing equipment, servers, switches, hubs, network devices, all manner of things that potentially have the ability to be compromised. So Amazon ensures that any changes to hardware, software, and network configuration goes through their automated change control process. So they have logging, auditing, and monitoring for every change that occurs inside of the infrastructure, inside of the system. Any physical access to these devices requires an authorization with frequent renewal. So just because I had physical access last month to be able to get to a device doesn't mean I can get it to it today. I have to reauthorize and essentially recertify to the people in charge at Amazon that yes, I'm supposed to gain access to these resources. Anytime anyone needs to log into these servers, they don't log directly into the servers. Rather, they go through something called a bastion server. And a bastion is a gateway that only allows privileged access and ensures that they can monitor all of the usage that's going on with that server. So anything that I'm doing or whoever is logged into the server is doing is being logged, monitored, and controlled by that bastion server, and it can be cut off or disabled at any point in time because they're accessing it through that gateway. They don't have to expose administrative credentials or highly privileged credentials to the hardware that's running. They only have to use it through the bastion server. All network boundary devices are monitored and audited for access. Network boundary devices are anything that the network uses to communicate with the outside world, as well as anything that the network uses to communicate with itself inside the network. So just like the physical data center, just like the building has locks on the outside doors as well as locks on inside doors to ensure that people don't gain access to different areas within the building that they're not supposed to, the network devices have locks to ensure that traffic and access is only granted to those areas of the network that it needs to be granted to. And then finally, of course, they have a number of different daemon services that are watching or monitoring for abnormal activity, application usage, intrusion, etc. This is important not only for protecting against outside malicious attacks that are trying to intrude on the service, but also inside the service as well, ensuring that people aren't misusing the AWS services themselves. So a great example of this is a story someone once told me where they wanted to do some load testing against an application, a service that they had written. And they decided a good way to do that would be to spin up a whole bunch of EC2 instances on AWS, little tiny cheap instances, have them fire up and hit a script that would just start hitting their service so they could see how well their service handled a whole bunch of load. Well, if you're familiar with application development at all, that looks a lot like a denial of service attack. That's a good way to bring down a service, and AWS shut them right down when he started doing this because they recognized that activity on their service as being malicious activity against someone else. Now, obviously, it was a misunderstanding that malicious activity was against himself, not against someone else, and it was for testing purposes. But the point here is that their activity monitor recognized that usage as being potentially malicious, and they stopped it. They cut it off. So AWS is always watching what's going on, both internally as well as externally on their network software, and they're ensuring that things are on the up and up. Now lastly, AWS offers some security in the form of regulatory compliance, and I thought about the best way to illustrate this, and at the end of the day I decided really the best way was just to go to the website and kind of print off the list of all of the various laws and regulations and certifications that AWS meets. So chances are that if you have to meet some regulatory compliance, you're going to find it on this list. Here's HIPAA, there's PCI down here, there's a whole list of different frameworks on this side. What's great about this is because Amazon AWS meets these certifications, meets these standards, a lot of that filters down and trickles down to you. So you can use the AWS service if in fact your data is protected or regulated by these different laws. Of course, in the true nature of the shared responsibility model, you still have to perform activities on your own side to ensure that you don't then violate that regulation by, again, exposing protected data on a publicly available website. But you know that the base level of infrastructure, the foundation services that Amazon is providing to you, do in fact meet these regulations. So that concludes this nugget on the AWS shared responsibility model. The big takeaway here from what we talked about is that security is both Amazon's responsibility as well as ours. Because Amazon is in control of some things, they go to great lengths to ensure that they have appropriate and high level of security on those things. But because we are in control of configuring the tools that we deploy on AWS, it is our responsibility to configure those tools in a secure manner. I hope this has been informative for you, and I'd like to thank you for viewing.